Figure 3.7 GradeBook.java. We're now going to build a more realistic class definition for our GradeBook class. In the first two examples of class GradeBook, we had just the display message method inside the body of the class. But most classes that we create contain both data and methods to manipulate that data. In this example of the GradeBook class, we've declared at line 7 a variable called course-name of type string. This declaration is called an instance variable declaration. For every instance of the class GradeBook that we create, that is, for every object we create, there will be a separate copy of the course name variable. Now we've made that variable private, which is a new keyword, to indicate that only the class GradeBook should be allowed to manipulate this variable. This is called hiding the data or encapsulating the data inside objects of the class GradeBook. And what that does is it gives us, as designers of class GradeBook, complete control over how the variable course name gets manipulated by the client code, the code that's using our class. Now, when you have private data inside your class, you will often provide methods for manipulating that data in a controlled way. And in order for client code to be able to use those methods, they have to be declared public. So you'll notice that we've got a private piece of data here, and we have a couple of new public methods in our class. A setCourseName method, which will be used to change the value of the course name, and a getCourseName method here at line 16, which will be used to get the value of the course name. It is not uncommon to have both a set and a get method for manipulating a particular variable's value. As you'll see in a subsequent example, the set methods inside of a class are often used to perform some sort of validation for values being placed into an object of the class. For now, we'll use what we call simple set and get methods, where in our case the set course name is simply going to receive as its argument the name that represents the course and assign that variable to the course name instance variable. Notice at line 12 that the course name instance variable is not declared in the method setCourseName. This is a special relationship that you have between the data inside your class and the methods inside your class. All of the methods, setCourseName, getCourseName, and even displayMessage, know about all the other methods inside your class and the data, in this case at line 7, the course name variable. Now there is an exception to that rule, which is a concept called static members of a class, which we'll discuss later on in this course. But for now, what I just said remains true. Now, so setCourseName is going to assign a new course name value. GetCourseName will take whatever the current course name value is and return it as a string to the caller. And displayMessage is once again going to output a message representing this gradebook. It's going to say welcome to the gradebook 4, followed by a new line character, and then this %s here represents the placeholder for the next value in the parameter list or in the argument list. GetCourseName is giving us that value. Now getCourseName is another method in this class. It's defined back here at lines 16 through 19. And we certainly could have said right here at line 27 the name courseName, which is the variable declared back at line 7. However, we're actually trying to take advantage of a good software engineering practice here that helps us modify, maintain, and debug our classes, especially as they get larger. And the basic idea is whenever you need to touch one of your class's instance variables inside of a given method, if possible, call one of your class's other methods to do that. So if I need to modify the course name from another method of this class, rather than just assigning the variable course name a new value, I would call setCourseName to do it. And similarly, whenever I need to retrieve the value, rather than just using the course name variable by name, we call getCourseName to do it. And what this does is, if we need to make changes to this class later on internally, we help minimize the number of places where we need to make those changes. And also, if something goes wrong in the manipulation of the course name, it helps us localize where those problems are in our code as well. So for example, if we needed to convert the course name variable to a different name, we could do so if in fact we change it here at line 7, and then we would have to correspondingly change line 12 and line 18 where we directly referred to the course name variable. On the other hand, down here in the display message method, we don't need to do anything because we did not directly access the variable course name. Similarly, if we set the variable incorrectly, or if in fact the value is returned incorrectly, we would know that it was a problem in the set course name or in the get course name method, and we could then go focus on those methods as the debug points in our code. Now, just like our other classes, we need to create an object of the class in order to use the object. So here at line 14 in our GradeBook test class, we're creating a GradeBook object called myGradeBook. And initially, we want to show you what the default course name value is. Now, it turns out that variables that are local variables declared inside of a method's body don't get initialized for you in Java, but instance variables do get initialized. So here's our GradeBook class again, and this is a non-primitive variable, a string variable. Primitive variables would be things like ints and doubles and other primitive types that we'll learn later on. Primitives get 0 or the equivalent of 0 as their default value. For example, a boolean would be false and an int would be 0. And non-primitive variables get null, lowercase null, as their default value. Now, over here we created the GradeBook object at line 14, but we did not give any default value for the course name. So when we call myGradeBook.getCourseName here at line 18, we are actually getting back that null value that was automatically assigned by by Java, and we're going to actually output that in this string placeholder here at line 17. And in Java, when you output the value null as a string, it actually outputs the word null for you. Now I'm going to stop here for a moment and go run this program for you. I've already compiled it. And when I run the program, you can see here that indeed the word null is displayed as the initial course name. Now we'd like to demonstrate to you our set and get methods again. Here at line 21 we prompt the user to enter the course name. At line 22 we use the scanner input object, which was created back here at line 11, to read the next line of text from the user at the command prompt. We then take the string that's returned and we use it in this call to set course name here at line 23. So the variable the name is passed into the set course name method on the specific GradeBook object called myGradeBook. And this is how Java is able to differentiate between many objects of the same type. Each one would be assigned to a different variable, and based on which variable you use to call the method, it will determine which object it needs to interact with. So this goes to the myGradeBook variable and assigns it whatever string we type in at the command prompt. We then skip a line in the output. When you use println with an empty set of parentheses, it just outputs a new line. And then we display the GradeBook's message, which is going to display as part of the message the GradeBook name that we just typed. So if we go back over to the command prompt here and continue by typing in a value, CS101 Intro to Java, you can see here that the display message outputs the string that we've typed in. So now we have a slightly more enhanced version of the GradeBook object, and in our next example we're going to demonstrate how you can initialize an object of a class at the time that you create it.
Looking to advance your career by acquiring new skills? Tired of expensive off-site training programs? Wish you could learn from the best instructors in the industry? Look no further than live lessons. Self-paced, personal video instruction by the world's leading technology publishers. Each live lesson comes with a DVD featuring 3 to 4 hours of instructor-led classroom training, sample program code that allows you to work along with your personal instructor, and an example-rich study guide. Live lessons allow you to watch the entire course from start to finish, or navigate directly to any of the individual lessons. You'll literally watch over the shoulder of your instructor as he shows you how to build state-of-the-art applications. Live lessons, the power of the world's leading technology experts at your fingertips. To learn more, visit mylivelessons.com today.